This video is going to discuss the different statistical analyses we can do for between subject designs. So the simplest design we have is when you have two groups and you're comparing those mean differences. So this is known as a single factor two group design. In other words, the researcher is manipulating one independent variable or has one factor and it has two levels. So there's two groups and we're talking about a between subjects, so each of those groups is independent of each other. And what we want to do is compare the sample means or those arithmetic averages for those groups of participants. Now, as you learned in statistics, you can calculate that all out by hand. However, here in this class, we'll be using SPSS. So again, imagine you have your two groups. You have condition 1 and condition 2. These are two independent groups of individuals. And the data that's important is that mean and standard deviation. We want to compare the means of the two groups, but that's not what you put into SPSS. What you actually put into SPSS is all the raw data. It needs all of that, so it can look at that standard deviation, that variability, comparing those means, and determine if the differences between these means is big enough, depending upon the variability within each of these groups. Now, the type of statistical analysis that we'll do with a two-group, when we're looking at a two-group mean difference or a single-factor two-group design, would be an independent measures t-test. And it's independent measures because we have a between subjects design. And a t-test is when we only have two means, we can use a t-test. It's the simplest statistical analysis we can do. And it will show if there's a significant difference between the means. So here's an example. A researcher wants to study the effectiveness of a new job skills training program for people who have not been able to hold a job. 14 people who have not been able to hold a job agreed to be in the study. The researcher randomly picks 6 of these volunteers to go through a specific training, and the other 8 volunteers are put through ordinary training. So here again we have 6 subjects in our special group program, and we have 8 subjects in our ordinary group program, and we want to compare the arithmetic means. So let's think about, just to kind of remind ourselves of all these different terms we're talking about, what's the independent variable? What is being manipulated? It's the type of group that they're in, if they're in the special program or the ordinary program. What's the dependent variable? What's being measured? The dependent variable is going to be the score that they got, the effectiveness of that job training program. So which is the control group here? Which one is going to be like our baseline? Is it this special program or is it the ordinary program? Probably this ordinary program group. All right, moving up in complexity, we now have a single factor multiple group design. So this means we have more than 2 groups. So here we have 3 conditions, more than 2. Could be 4, could be 5. Sometimes they can be very complex. And we still want to compare those means and standard deviations. Now, sure, we could do a t-test between condition 1 and condition 2 means, another t-test between 2 and 3 means, and then another one between condition 3 and condition 1. Then we've compared everything, right? However, each time you do a t-test, you're introducing error. What we want to do is reduce that experiment-wise error, and we can do that by doing a different type of statistical analysis called an ANOVA. When you have more than 2 groups in your design, you want to do an independent measures analysis of variance, or a one-way ANOVA. And again, we'll be doing all this on SPSS, so if you're going, oh my goodness, all those calculations again, you don't have to worry about that. You just need to understand the interpretation of the analysis. So here's an example for that. A researcher wants to know which test preparation strategy is most effective for college students. In the study, the researchers had the students read a passage and then assign them to one of the 3 treatment groups. Group 1 participants reread the passage. Group 2, the participants answered the questions that tested their comprehension of the passage, and in Group 3, the participants were asked to formulate their own research questions. The next day, the participants were tested on the material. So what's the independent variable? What's being manipulated here? The type of test preparation strategy. So what are the levels of that? We had 1, 2, 3 levels of that one factor. The factor was the type of test preparation strategy. Participants reread, participants answered questions, or they formulated their own questions. So those are 3 variations of test preparation strategy. So what were they measuring? They're going to be measuring their retention of the material. That's the dependent variable. So the researcher predicts the independent variable will affect that dependent variable. Now, when your dependent variable is measured on a nominal or ordinal scale, so the last two examples we've had have either been interval or ratio. So we can use t-tests and ANOVAs. But when we have a nominal ordinal, data has to be analyzed with what's called a chi-square test for independence. So it compares the proportions between the groups. So you look at the proportions that actually were a result of the experiment, and it's compared to what was expected. So here's an example for this. A researcher would like to know which factors are most important to people buying a new car. Each individual in a sample of 200 customers is asked to identify the most important factor in the process: performance, reliability, or style. The researcher would like to know whether there is a difference between the factors identified by younger adults compared to those identified by older adults. So what's the independent variable? And it's not necessarily being manipulated. This is more of a quasi-experimental study. So they're comparing younger adults with older adults. And then what are they measuring? What is the most important factor in buying a new car? So whether it's performance, reliability, or style. So the idea is that you would expect these 200 customers, younger and older, to be evenly distributed amongst these three. If they're not, then it shows you have a difference. So that's where you have your expected probability compared to your outcome probability.